Okay, so these are some of the reasons why you might have an error. The last one here is usually occurs when your system runs out of memories, right? Because it's either caused by your own program that you write and you forgot to close all those resources, like you have open a lot of connections and you don't close them, and it consumes resources, and then it kind of ran out of RAM and it closed that program. So, but there are two types of errors. Okay, it's categorized under two major umbrellas, and they're just basically called error and exception. Okay, so the error is usually referred to something that is very fatal to your program. It can cause your program to crash and stops functioning. So those are the errors. I mean, so when we use the term error in coding, it's been used very loosely, right? To means like you have an incorrect calculation, incorrect read-write files, and things like that. So those are very being used very loosely. But technically, there are two types. When we refer to error, is something that can crash the program. Again, back to the example, we talked about running out of memories, or you lost a network connection. Sometimes those situations you cannot handle, right? You don't have control of it. It's a systemic error, so sometimes you're just out of luck. But that really happens, but it does happen. The other type is the exceptions. Okay, exceptions has, a lot of subcategories under those, and these are not that fatal. If you can handle them, if you know to handle those very gracefully, then your program will still run very smoothly. If you don't handle those, then yeah, it can cause your program to crash or stop functioning too. So we'll look at some of those. And this is it's kind of hard to see here, but let me see if I can fit this into like a, continues on down here, okay? So this is to show you like a hierarchy of where those errors are coming from. So we learned at the very top of all Java object is the object class, okay? So everything else are descendant of that class. Then under that object class, there's another class called throwable. Okay, so that throwable class allows you to throw errors or catch errors. Okay, so under that throwable class, then you have the two major error types. The exception here, as you can see, there's a lot of subclasses underneath that. We learned about inheritance last week, right? So exceptions, and if you follow this line down here, the exception, the second line here down near to the next one, you have others, but one of these is the error, okay, the error class here. So the error class is, again, back to that very fatal types, okay? So we'll be dealing mainly with the exceptions class because it's something that you can handle. The error, not so much. Okay, so that means under the exception class, you have a lot of subclasses as well. You have one is called another major type under exception is the I/O exception. This is for reading input output. If you can read a file or you cannot read a file, if you can't output to the console, that will be handled inside this class here. Under the next subclass is the runtime exception. This is when you have errors during runtime, right? When your application is running and it encounters some errors. So usually encounters like incorrect data type matches, right? When you do, I'm sure you do this already. You read input and you're expecting an integer, but you put a character, right? It crashes. Those are the runtime errors. It happens during runtime. And so most of these will be like a lot of the arithmetic exception. Classic example is division by 0. That's handled by this arithmetic exception. Another one that's very, very common, very popular is the index out of bounds exception, right? When you deal with strings or arrays and you try to access some index that is no longer fits out of the boundary of your maximum size, then you get an error. Anything that's not within a boundary, okay? The index here is very broad. That includes both strings and arrays. The array index out of bound is very specific to arrays only, so you can see how that's been used. And one more down here is like no such element exception. Okay? If you try to access something like in an array or a list, and it's nothing there, then it would get that type of error. And there are many others as well. But these are the most common ones you will see all the time. Okay, so again, put into perspective the language object class, and then you have durable. The errors are the fatal types, and then the exceptions are the less fatal, and less serious, and those can be handled. Okay, and then let's see. Something about the stack trace. You've seen that before. When you run the program, it looks something like this. So that's a stack trace. A stack trace in Java, and not just Java, in most languages, when you run your program, even like in JavaScript, when you run, it crashes because it's caused by one of those code or statements in your program. It will tell you where those errors occur and at which level, which layer of your code. And usually these are caused by either functions or classes, right? And it will list from here will be the bottom. If you go from the top to the bottom, that means you start from the bottom, you go all the way up, you trace the stack. The stack are functions. So every time you call a function, Java adds that to a stack. And that stack call keeps track of all your functions in that order, in order of execution. And so when it crashes or something happens, then it pinpoints exactly where the error is in that function. It will tell you also the line number where that code is, right? Okay, so the very top line here is the error occurs. Where is it? I mean, how do you get to this place? If you follow this track, if you trace it down to the root of it, okay, you start it always, again, in this case, always from the main method, right, the main program. And then from there, you must have read, in this example, you must have read a scanner read. You did another scanner read, and then you got an error because you have a division by error, or you have a mismatch, right? Because you entered 3, you're expecting a number, and you got an input mismatch, right? So that's one of the errors you get. Same thing here. I'm trying to get a integer, but I enter my second number as a double or decimal. Then again, you get an input mismatch error. So you can track and trace where those error occurs if you look at that stack trace. Okay. And this is how you can call errors. We'll do the example in a minute here. Okay, let's see. Okay, so did I talk about the try catch? Yeah. Try catch. Let's see if there's another. Yeah, let's go back to the try catch here. Let's see. I have another place. Okay, yeah, this is the syntax here. Okay, so you catch errors, or you throw errors using a try catch block. And usually you also have the finally block too. So try catch finally blocks. Okay, and in the try block, as you can see, you put the keyword try, and then in the parentheses, curly braces, you put your statements in there, and then if there's any error occur, you will catch it in the catch block down here. Okay, and the reason we use try is maybe one of these statements has an error that you don't know what it is, but you have a feeling, you have a gut feeling that something in this block of code might cause an error. Okay, and that's when you want to use a try catch. If you know for sure there's no error, then you don't need to put it. If you think that you're not sure, and this is very, very common, especially when you do a calculation of any data, especially division calculations, or when you read a file, read a text file, you read an input from the user, when you read a database, then that is usually you put into a try catch. And the reason is because of this try catch block thing, it lets you handle errors very gracefully without crashing your program. Okay? If you don't do that, then you can still handle it. You can do it yourself. You can do it manually. Okay? You don't have to use try catch. You have to validate it and then make sure it's valid and so on. It's the same thing, the same idea. It's just that using the try catch, you handle your errors in its own logical way, and you categorize all your errors and you put them into their own areas so that it's very, very easily maintained and managed rather than writing your own exceptions. Okay, these are completely optional. You don't have to use it, but why not use it if you can, if it's already provided. Okay. So the syntax is like you see here, the word try followed by a pair of curly braces. And inside here you put your statements. It is just regular code here like you normally do. And then if there's no error, then the catch blocks here will be ignored completely. Right? You don't need to go in there if there are no errors. If there's an error, then it will be caught by a catch block down here. Okay, so the catch will come after the try block. Okay, it needs to come after it. You cannot come before it. After the try block, and it usually comes immediately after it. And then inside that catch, it's like a function. You put in an object in there, right? So exception is a data type. It's a class type followed by a variable. And then you can, because now this variable, this object, will contain all types of information about that error. It can tell you what error it is, what type it is, the error message, what the line number is, and so on. So it will get those information, and you can output them to the console or, print them out. And then you write the code here. After these statements are executed, then it will go out of the catch block and your code continues on. Right? So in a way, you handle the errors very gracefully, and that doesn't crash your program. If you don't do that, whatever it finds in the error here, it will break there, and the system stops there. So here's an example for that, right? So here we do a try catch because we are not sure about the denominator, right? This, again, back to the classic example about division by 0. I'm trying to divide two numbers, and if the denominator is non-zero, then, it'll be fine, no problem. The catch block will not run. But if I happen to have an input coming in and the denominator is 0, then that line right here will crash. So when you evaluate this result is equal to numerator divided by denominator, it causes an error. And when that happens, then that error will be passed on to the catch block down here. And then it would say it's a arithmetic exception type, and then we'll print that out here. You say there's an error, and you can message your own error messages to the user or to yourself. Especially useful when you do debugging purposes. You test everything, make sure it is working correctly, then so the user don't have to see this. So, okay. This one here is about something similar, except now you have the index out of bound, the array index out of bound. I have an integer of 2 elements. I'm trying to access a third element, and it's not there. Or actually the fourth element, right? And then it crashes. Okay. Another thing is you can do a multi-catch block. As you can see, you can catch a lot of them. I think you cannot do this in Python or JavaScript or even like PHP because again is the it's based on the language type. Okay? It's a loosely typed language, so whatever you pass to this is going to be, it doesn't matter in those languages. But in Java and like in C++, C#, they are statically typed so that you can have a unique signature. That's why you're able to have different catch blocks. If you remember back to the overloading, right? Same idea. you have different exceptions, so different signatures, so therefore you can have different catch blocks. And because you can do this, you can be very specific to a particular exception error, type of error. Maybe the first block will catch inside here, whatever your code is. You will have a couple lines of code that can occur, and you can have like division by 0. You might have an input from the user. You might trying to process an array all inside the same try block here. And so you have 3 types of errors, and you want to catch those separately. So you can do 3 catch blocks to handle each of those separately. Okay, so you can take 1 catch or multiple catch blocks. And the last one here is the finally block. Okay, the third block is called a finally block. This one here, usually it comes in this fashion: try, catch, finally. Okay, the rule is if you use a try. Okay, so try cannot be by itself. You cannot just have a try and then you stop there, because you have to catch it some way. So if you use a try, it must follow by either a catch block, at least one, or a finally block, or both. Okay, so try can go with try catch only, try finally only, or try catch finally, or try catch finally. Right? It doesn't matter. And again, finally cannot be by itself either, nor do catch. They must have a try. So that dependency thing. Okay. And I think the order is, we'll have to test it. I don't remember. I think it is important. Try, again, must be in top. Catch will be in the middle. And finally is always the last block. Okay. And the finally block here will always run regardless of what you have up here. So whether there are any errors or not, the finally will always run. Okay? But up here, the catch only runs if you have an error in the try block. And then if it does, then it will run your try. If there are no errors, then it jumps to finally. If there's you run your try. If there's an error, then it goes to your catch. After that, it still goes to finally. Okay? So the reason or the purpose for the finally is basically just like clean up stuff for your code. Maybe because like up here I might have an input, read, or I might open a connection to a database system, and I didn't get a chance to close because my closing statement is towards the bottom, but my error occurs above. So that would loop the code or the run head to the catch block, so I never get to close the file or the system. So that's why you put it down here in the final block. Okay, if you open it, do the errors, close it. If there are no errors, still close it. Okay, so it's like the final thing you need to do inside the block here. So always execute. All right. So let's go into our clips and see if we can do some code in there. If you have any questions, just stop me, okay? Just pause. Okay, so this is inheritance. We did last week. I'm going to close these, and we are going to create a unit. A new project, unit 11. And I'm going to create a package. This is chapter 11. I don't know. We'll call it exceptions. Then let's create a class. I just call it main program. And then we'll have the static main. Then finish. All right. So I put here error handling, or I should say exception handling, that's the same. Before I do that though, let's read. Let's create that scanner read first, because we're going to read some data from the input. And go ahead and import that class. You notice that in most of my examples, when I do a read, I did not close it. And sometimes if you forgot to close it, it will tell you, say, oh, you forgot to close it. You should close this input read. Okay, so usually you do that at the very end, because I can have another input read, right? This is one of them. I can have another one. Maybe this is like input 2 and 3 and so on. So one can be used for reading a different input, or for another. I mean, theoretically, you don't really need so many. But sometimes you do have those inside, like, let's just say this is a local, it's a local variable, right? Only in the main class, main function. If I have another function down here, I might declare another local read down there, and so on. So usually you don't have that many, but sometimes you can, if you want to. You want to differentiate them. One is like maybe from the console, one is from a text file or somewhere else. So again, this is local only to the main method. And usually when you open it, you should always close it. Okay, so at the very bottom, you can close it. Or usually, you would put a function to close it, like static void, and then close input or something, right? And then here you put the input, like the scanner input. And then over here you say input.close. So when you write your code up here in the main program, when you're done, you just say close input. And you pass to it. You can do that, or because it's a function call, you can use it everywhere else. You just say input.close, and that's fine too. But why not use functions? It's because you can pass any input to it. So let's just say we'll just keep that here for now. So make sure you don't, because once you close it, you can't use it again. Okay, you have to reopen it again. So if I close it after this, if I try to read it again from the input, it will say input is not, you can't open the stream. So you have to reopen it again. So make sure that's only the last thing you want to do here. Okay, so let's just say that we're going to read an input from the console. So we'll do a sysout print, not print, just print, and enter a number. All right, so here we're not validating. And if you really want that to be a number, then you would validate it, right? So the integer in equals the input next int. And then all we're going to do is we're just going to print it out. Sysout you enter and then in. Very simple. Okay, so when you run the app, enter a number, you put a number 5, and this is you enter 5. Right? So, no problem there. We've done that all the time. The error happens when you run and you enter a letter. And there it is, right? You have an error. So because we did not handle the error type, if you look at this, and I don't know why I can't make this. You know, it's let me just do this fix really quick because I want it to be really large. It's very hard to see. And where is it at? File properties. No, not properties. It's a project. Okay. It's in the editor. Code stuff. Yeah, this tool makes it really hard to fix these. I wish to make it a little bit simpler. It's not there, I guess. Let's go over here. General, under the editors, under the text editors. Line numbers, color. Have, what is it at? Rotation, hyperlinking, link, appearance. Oh. What space? Yeah, I can't find it. They make it too complicated. It's not so helpful. But you can go in and change the console for the font and so on. And here I can make it. I can't use my mouse scroll either. But let's see if we can do some trick here. Window plus plus. Come on, there we go. I'll just zoom in. Okay, so you see here that this is the stack trace. Okay, I showed you earlier. So we start the program from the main program, and then we did a input int. We read the int, and so this is a process here. So you read that first, and it passes on to the next class. This happens behind the scene. You don't get to see this. Okay, next int, and then it converts to a next function. And then it trying to match the number because you're expecting an integer, but then we got a letter T instead, right? So therefore, it's an error, and it throws the error. Okay, this is where it throws the error. And then when it throws the error, then you get the message here. This is the message of the error. Didn't tell you much, but just say the error is in the main program. Occurs in here, and it's the type of error is a input mismatch exception. So I notice the word exception is always at the end of these messages. Something about, array out of bound index exception, or input exception, or something like that exception. It's a convention. And later when we write your own exception, we'll do something kind of similar. Okay, so this is called a stack trace. Every time you run a function, it goes in here. So just to show you that, let me go back here. And how do I zoom? Cancel my zoom. Okay, confused. Okay, so for example, if I let's just say I write a very simple function down here. Okay, public static void test function. So you know what happens when I say stack. Okay, so inside the stack, let's write another one here. Public static void done, for example. And then we'll just call the done inside the stack, the test. So I'll put done in here. And in my main program, I'll read the input, whatever it is, and then, well, before I do, let's see, done. Let's see. Yeah, let's go here. You read the input, enter number, you print it out, and then go here of what I call the test function. Yeah, I'm not sure this will show, but let's see. I call the test will call the done, and then done has nothing, right? And then you close the input down there. I'm not sure this is what I want to show you, but let's see what happens. I type in a number, then no problem, no error, so you don't see the stack trace. If I run it again, enter a number other than 5, yeah, it only runs those functions that were current error. Let's change this a little bit, okay? I'm going to put these inside the test. Yeah, so let's just say we read the input here. I'm going to call test up here. We'll call test, and we're going to pass input into test. We'll change that down here. So it will be scanner input, kind of like the close down here. Then I'm going to move all of these out inside the test. Okay, you put it in here instead of the main program. So the input comes in here, you read input, and then the output here, instead of the system out here, I'm going to save this and move that over to the done section. So I'm doing like making function calls from one function to another, and I'm passing the input to that. Well, actually, you know what? Maybe we'll put this input inside the done, like that. So there's two statements in there. So the task is to read, just output the message, and then we call it done. But then we have to pass the input there too. So again, input goes to done, and this is one of those reasons why sometimes you want to put the scanner into the object, into this global space. Because I'm using that all over again, I'm passing to a function, and if I'm going to use the same scanner read, then yeah, you have to pass it all around. If that's the case, then you put that scanner in the global space. And so I don't have to pass to those functions. But this is fine too. You learn how to pass data from one function to another function. Okay, so now if there are no errors, when you run this, it should work just like before. Okay, I'm just removing my code around. Okay, so when you do that, this is called refactoring, right? You refactor your code. And you can't just like grab and put it everywhere else. You have to handle some things like passing the input to the correct functions, and you pass this around. But let's just save this and run it again. See that it works just like before, flawlessly, like no errors. If I type in number 7, it should print 7, right? No problem. Run it again. If I enter a letter T, then now we have some errors. Just like before, except now we have more errors than before. Okay, if you look at this now, you see that it trace all the function calls. Okay, when you make a function call, it adds that to the stack, to the Java stack, and so you can trace it. That's what it's called a stack trace. Okay, so the error occurs again when you read the input and you try to compare the input of t with an integer. You get some error. So these are the same as before. These are the three functions that you call. You call from the main function. The main function calls the test function. It calls the done, and then the error occurs in here. Where does it occur? At line number 22. Right? It calls at that line number. So if I click on the line 22, it takes you right into that spot. If we go back, so it takes you right into that error. Right? Line 22, if I want to call, okay, the test function was called in the main program. Where is it being called? At line 18 in the main program. If you click on it, it takes you right into that, or from the line 18 here. Right. So it tells you exactly what they are. Okay, so when you trace this, and since we have the input down here, then you want to, and I'm going to focus in here now, since we put it in here. It's the same thing that's going up here, right? I'm just going to put it here so we can see it. Put a plus plus here. Okay, so in here is where the error occurs. So usually you need to handle this, right? You want to make sure that if n is not an integer, then you would say enter again, try again, right? So here you can say, how did we do it before? So you can say if, so you would test it, right? So usually you would put like char here, and then input is not next int, but a character. So you can say next input dot there's no next char. I don't think it has a character. Or you can use the string, which is the next line, but then you want to grab only the first character. Or if you read as a string, well, let's do this. String, let's do this. String temp input next. So you read the whole string in. And then usually you have to validate each number, right? Each character at a time. So you can say if for, see how hard this is, right? For int I, the index, starting at 0, I less than the length of temp, and then I plus plus, right? And then you would check if the temp of I, okay, in this case is a character, right? If it's a 0, or 1, but so you don't want to get a temp here. You want to read a character. Say char c is equal to temp of I. Get a character, and then you can do, what is this? Let's be an array, a result to a string. Okay. Yeah, well anyways, yeah, you can see how complex this gets, because all I'm trying to do is to validate, make sure that it's a number, right? Because you cannot just use the input next and then expect numbers. That's your intention, but then how do you know that it's going to be all numbers? And I know there's This is a better way to do this, but still you can write your own function to validate your numbers. And what I want to do here was do that. It's a string. Oh yeah, this is an array, so it doesn't work. It has to be temp character at I. So what I did was I'm reading each character. If my number was like this, if I put like 1 to D5, something like that, right? So you want to make sure that it's a valid number. And if you just put that, we saw earlier that the system crashes. So before it crashes, before you do this, I want to make sure that it's a valid number. If it's not, then you throw a nice message to the user. That's the whole point here. So I check the character. If C is, if that character here, the first number, 1, if it's, so I don't have to match every single number from 0 to 9. I would just say if this is larger than 9 and larger than equal to the character 0, like that, right? Or actually, yeah, it's larger than 0 and C is less than equal to 9. If that's the case, then that's a valid number. You move to the next one, right? The next one. But you take the reverse of that. If it's not equal to this, so you put the 9 in front, right? If it's not that, then you throw an error here. So you just out saying try again, right? Not a valid number, try again. And then what do you do here? Well, you go back, you call the other function over here. You call the test again. It does the whole thing again. It's like going through a loop here. So you can say test again. And then finally you put, if it's all correct, you put a temp down here. Okay. So I did all of that. It's just to validate my input. And I'm not guaranteed it's going to work either, but let's give it a try. Okay. So I read my input. I check the character at a time. See if it's all digits. If they are digits, then go ahead and print that out or do my calculation. At that point, it's a string, so I have to convert back to anything I want to do for operations, right? Math operations. But let's just see if this works. So here again, oh, I have an error already. Up here, oh yeah. How to get this here? I don't want that. It asks automatically for me. Okay, so let's run. Again, if I enter 6, 7, 8, that should be fine, no problem. Okay. If I enter T1, 2, 3, right, you see that, and now I get the message, let's try again because it's not a number. Then it calls the function to the test function to input. All that does is just to enter this message here. So input again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's valid, so you work good. Okay, and notice again, there's an error here. Right? I have T1, 2, 3 up here. If I enter 2, 3, 4, 5, 6, and I have 2 of them. So something's going on there. And that's because I'm looping through the whole thing here. Okay, so you do all of that just to capture that the message there. So this is error handling. You do your own way. This is the traditional way of handling errors. So now with the try catch, you don't have to do all this stuff here because the error will be detected by the program itself, and it just tells you. Right? So we can omit all of these and go back here and change this back to int. And I'll read int like before. Okay, and I'll put that int, yeah, that down here is fine. So before I do any of those output at the bottom, I want to make sure this is correctly entered. So that means I want to wrap this inside the try block. Okay, I'll just say try and read this input here. Okay. If it has no error, then go ahead and print it out. That's what this means, right? I'm going to move this up here so you can see it better. Okay, if it's no error, then try it out. As you can see, this is temp is not visible. So this is another thing here. When you do the try catch, any variable you declare inside the try block here is not visible outside. Even though, if you think about it, this is just a block. So if you go back to the term where how we do the scope, right? This is a scope, right? If I declare a variable inside here, it's only visible inside here. Outside, if I try to access it, it's not accessible. The same thing applies here. So in my try catch, I'm reading the input for temp, but when I print out, it's not guaranteed to be outside. So therefore, when you do it this way, you want to, if you're going to print it out like this here, outside the try block, then usually you want to declare this outside of your block. Just an empty, actually you can't leave it empty. You can set that to a default number of some sort. Okay? Because if you don't set it, you can't print it, right? We learned that before. So set that to a default number. And then now we're going to read the number. And if there are no errors, you print it out. If there are errors, again, you cannot leave the try by itself. You have to catch it. And the catch takes a function. It's like a special function. And inside here, you put the error types. So usually, you can put the exception class. This is the large class for all the errors, all the exceptions, right? It falls under this huge umbrella called exception. So it's like a catch-all. So if there's an error inside this block of code, that error message is passed to the catch through this object called E. This is just a variable name. I call it A, B, C, X, Y, Z, doesn't matter. Okay, just a variable name. Just like anything up here. And then you want to see the error, then you can print that out. So you can say sys out the error message, the error, and then you put the error message here. You can say E dot. If you type the E dot, you see it has a lot of all those properties. Okay, and one of these is called the message. You get the error message, and also it has a get stack trace, right? If you want to show those red stack trace, like you saw earlier over here, then you call the stack trace. But I've just put the get message. It's a setter and it's a getter, right? Then I'll put the message here, what the error was. And then after that, now we're outside of the catch block, then we go and run this statement down here. So therefore, even if I put an error, it will still continue on in printing the message. So it won't cause the error or the computer to pause where the error was before. It won't crash. So now if I run it again, okay, you see that now if I enter a number 5, right, no errors, that's expected. Now if I try again, I think it's a shift 11. Okay, so if I enter a letter T, and then it throws an error. In this case, is null. Interesting. But then you see that the program still runs. Okay, it did not crash, right? It didn't stop. It continues on because I have my default number is set to 0. And if I try again, if I type in 1, 2, 3, ABC, yeah. So it didn't crash it, but I wonder what I have a null there instead of a number. Let's see. Error E message. If I just print E, what happens? probably an object. So yeah, it would just put the actual error message here. It would say input mismatch exception, and the error message was null. They didn't put any message there. Usually if there's a message, they will put there. Like, for example, if I do this, okay, if I do, let's just attempt is legit, and I would say int total equals 12 divided by 0. I just do this on purpose, okay? Because this will cause an error. This is fine, but this will cause an error. The error occurs on line 29. It's going to go to the catch anyway. Okay? So I put two possible cases in here that can cause an error. The first case, if I enter an invalid number, then it will jump to the catch phrase. If this one has no error, that passes, then it goes to the next line. In this case, if there's an error, it will go to the catch, right, and so on. So if I go ahead and run this now, okay, so I enter a number, 5, no problem, and then I get an error. The second line says division by 0. So you see that I have an arithmetic exception, and this is the error message. The message was divide by 0. Okay. The other one, when I enter if I enter like the first one is letter T, it did not give me any error messages. It just said null before, right? There's no messages. It tells you the type of error, but it didn't any message. So that's the difference between the two here. One has messages, one does not. This one has a message. Okay. It tells you what it is. So you just saw that when you put message or code inside your try block, because both of these could potentially cause an error. And whichever the first occurrence will stop execution at that point and jumps to the catch block. Okay, so that means this line will never get run if the error occurs here. Okay, it will skip the rest of the code inside the try block and moves away and out to the catch if there is a catch. If there's no catch, then it errors out. And then if there's no catch, then your program halts at that point, and you're not going to see this thing down here, right? If there's a catch, then it will continue on with the code, so the program continues. So this is a catch-all, and you saw there's two different types. This is for invalid input, mismatch input. This is for arithmetic error. But they both are caught by the same catch. Because I'm using a very broad class here. This class is a catch-all. Okay, it's a catch-all. It's catch all errors through this class called exception. It doesn't matter what the error is. It could be division by 0. For example, I could make that legal, so that's okay now. If I do a, for example, if I put string, array, yeah, just an int array, a of 1, 2, and 3, right? Array, and I try to access the index out of bound. For example, if I try to do a total equals 12 divided by a of 3, for example, right? 3 is an error because 0, 1, and 2 only. 3 is out of bounds. So this line is fine if I enter correctly. This will be okay. There's no problem here. But the problem occurs here when I try to access the third element. It's not there. So then it will still be caught by this catch because it's a catch-all, all types. Okay, so we run this now. And let me go up here to the zoom box. If I type in 5, right? All those lines are okay. Except when I get to the index, it says index, array index out of bounds exception, and the index is 3. right? And that's true because we didn't have 3 in the index. This is 0, 1, and 2. I'm trying to get 3. Okay, so this one catches all of that. So I have 3 types of errors here, of possible errors. That's why I want to put into the try catch. This one, it's pretty obvious, so you may not even want to put there because once you set this, this is fixed. So if you just put 3 here, it's just your bad error, right? Because it's not arbitrary. You know why do you put 3 there? It's a syntax error. Not syntax error, it's just your own logic error. But if it's unknown, then yeah, you want to check it because the array, if you're reading this from another file or another code, you don't know the size of this. So if you try to access this with 3, yeah, you might get an error. It's unknown, so you want to catch that. So instead of doing a catch all, you can make your code a little bit more specific to a particular error. So that means you can put multiple catches here. So I can close that one there. I could do a catch here as well. One catch for the first type. And then I can do another one here. A second catch for the second type. So I have 3 types. 1, 2, and 3 types. 1, 2. This is the catch all. So I could do one more down here for the third type. So I have 4 catches here. The first one is going to be, what type is it? It's a mismatch type, right? So here you'll be like a input mismatch. I don't remember the class here, but let's see, exceptions. Let's see. Exception. Input I think mismatch, I'm guessing mismatch exception. And yeah, so you can import that. It's a class, so you need to import that in. So if I go to the top here and in all my classes, so instead of having all these are under the util, so I could just put a star there if I want, and that should import all those for us, right? We learned it before. I put a star here. I'll leave it as is. So input mismatch exception. I put E here if you want. The second type is a division by 0, if possible. So that would be a arithmetic. Let's see, exception. Again, put E there. The next one is array. Not array. I'm not using. Yeah, it is array. So array index out of bounds. Okay. If you remember, just type array index and then just press Ctrl T, and it will add that for you. It's pretty cool. So those are 3 very unique or specific types of errors. Because this one is a catch-all. I don't know where it's coming from. Which error is it, right? So it's very broad. But now I can know exactly what type of error. So if it's a mismatch, then I can put a more meaningful message here. So I can say something like, incorrect, invalid input. Right, so that's a message. You put that for that particular type. This one here will be a more meaningful message. You can say, can't divide by 0, because I know that's a division by 0. And then the last one here is something out of bounds. So you can say index is out of range. And then this is a very broad one. If it's none of these 3, then this will catch it. Okay. And again, these are not syntax errors. Okay, if it's syntax error, you have a compilation error to be caught, but occurs only during the runtime. So now, let's save this and I'll run it again. This time, if I type in a 1, right? So I get a very specific message now because my error occurs in the index when the index was out of range. So I got that particular message out of that index instead of from the very broad message here. If I fix the total, so set back to 0, divided by 0 again, I save and run that now, and if I put anything there, I get a message saying you can't divide by 0. So it's very specific to the error that you put in here. And last but not least, if I type in a letter T instead of a number, I get an invalid input. Okay, so the kind of, you put your code in their own specific area, so they're very specific to a particular error, instead of all in the same catch here. Because now you have to filter out what type of error message is it. Is it a mismatch? Is it an out-of-bound index? Why go through all those if and else block when you can actually capture those directly up here? Okay, yeah. So let's take a break. We'll come back and then we'll do the other part. Try catch. Yeah, I forgot. Way past the break line. Is it being recorded here?